Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website, arifpat.me. The other way is to download all the notebook files from course GitHub account, Arif PUCIT, and all the notebooks for this course are housed in this public data science repository. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888, and here is the notebook for lecture number 6.11 of the 6th module, Overview of Machine Learning, for the course titled Tools and Techniques for Data Science. Well, this is the 5th session on data preprocessing and feature engineering, and today we will practically understand the need and importance of extracting and combining information from the features of a dataset. So let's move ahead and see the agenda of today's session. We'll start with a quick recap of data preprocessing and feature engineering. Then we will understand the need or requirement of feature extraction and merging the features. We will do two examples to understand feature extraction. First, we will extract different pieces of information from a student ID column in a dataset. Then we will repeat the same for DateTime column of a dataset. Well, my dear students, finally, at the very end, we will see a practical example of merging information from multiple columns to a single column. It appears to me that this will be a short but informative session, so let's start playing. My dear students, I always start by saying that this data preprocessing is the process of making your data ready to be fed to the machine learning model, while this feature engineering is the process of using domain knowledge to extract features from raw data via data mining techniques. And these are the 6 tasks that we normally perform in this phase, and we are done with the first 4, that is detecting and handling outliers, missing values imputation, encoding categorical features, and this feature scaling. Today we will discuss the last 2, that is extracting and combining information. Consider this construction date column in this dataset that has a date timestamp for each record. In its current format, it might be difficult to pass this feature to the machine learning model. As we have seen that in linear regression algorithm, the model will try to multiply this value by a numeric coefficient, which is not possible in this case. So we need to extract information from this column of construction date, and one way is to extract the year, month and date information, and instead of having just one column, we can have 3 columns, like one for year, one for month, and one for the day of the month. Similarly, my dear students, we can combine multiple features into one or lesser number of features. For example, we can think of merging the 2 features like number of bedrooms and number of bathrooms to a single feature, and this is called dimensionality reduction. To do it manually, you need to have sound domain knowledge of the dataset in which you are working. Inshallah, in the later part of this module, we will see dimensionality reduction algorithms like principal component analysis, linear discriminant analysis, and non-negative matrix factorization, which actually automates this process by preserving the salient relationships in the data. Well, I think enough of theoretical discussion. Let's move ahead and do this practically. And let us do an example of extracting information first. Let me load this dataset, a toy dataset, using the pandas read CSV method into our data frame df. This is just a hypothetical dataset that I have created to make you understand this concept. It has just 2 input features, ID and CGPA, and the output label is scholarship. We are mainly interested in this ID column of a student, and This is the format that we use at our university as well. Every ID, as you can see, consists of 10 alphanumeric characters. The first three actually represent the degree program: Bachelor's of Data Science, Software Engineering, Computer Science, and Information Technology. Next three represent the badge, that can be fall or spring with the 2 digits for the year. The seventh alphabet represents the session, that can be morning or afternoon. And the last 3 digits are the roll numbers of a student. Starting from 500 onwards are for the new campus students, while the roll numbers of old campus students start from 1. So there is a huge amount of information that is there in this single column. And for better analysis of data, we may need to extract all this information and place it in separate columns. Well, here is a piece of code that shows one simple way of doing this. I have used the slice object to slice different parts of the student ID. Let me show you as how we can apply these string methods on every item of our data frame column. Let me show you the just the ID column. So this is actually a series object, and if I check out its type, it's of course a series. Well, if I say df id dot, let me apply a lower method, the string lower method on this. So this has raised an error that says that series object has no attribute lower. And however, we can of course apply the lower method on individual elements of a series. Let me do that by just using the subscript operator. So it has converted the first value as over here to lower. Great. And to apply the string method on all the values of this panda series, we need to call the str.method name. So we have to do dot str dot lower and maybe dot str dot upper or whatever. Great. I think now this code cell makes sense to you now. In the first line over here, let me highlight it. I'm creating a new column with the name of degree in the data frame df by extracting the first 3 alphabets using this slice operator on all the values under the ID column. And then I am extracting the badge, then the session, and then the roll number. Note, while extracting the roll number, I am using this as type method of data frame to typecast the string to an integer. And finally, over here in this last line, I'm using the numpy's where method to create the campus column. I am assigning a value of new campus, this value, where the roll number part is greater than 500. You see this condition? When this condition is true, this new campus will be returned, and when this condition is false, this old campus will be returned. So this will be a new column containing new campus or old campus. For all the students having roll number greater than 500, it will be new campus, and for all the students having roll number less than 500, it will be old campus. So let me execute this. Great. My dear students, from the single ID feature, actually we have extracted 5 new columns representing the degree, the badge, the session, the roll number, and finally the campus. Now with this data set, we can perform better analytics than it was before. Let's move ahead. Let's do another example of extracting information, and this time from a DateTime column. And this cryptodata.csv file actually contains a subset of stock market data. Let me load it in Pandas data frame. So here it is. Well, actually, this data set is related to cryptocurrency. You might have heard of Bitcoin, which is actually a decentralized digital currency created in 2009. And this particular data set is related to Ethereum, which is a transactional token that facilitates operations on Ethereum network and uses blockchain development to replace storage of consumer data. Note this date column, which shows that the records are broken down into 1 hour's segment. So this is 8 p.m. and then we have 7 p.m. Then and over here we have invalid string. Then we have 5 p.m. then 4 p.m. and so on. Let me show you more records. I hope this makes sense to you now. Well, this symbol column that shows that it is Ethereum US dollar. This open and this close columns show the prices at which the stock began and ended trading in the specified period, which is of course 1 hour in this data set. This high and this low column actually refers to the maximum and minimum prices in a given time period. And finally, this volume column shows the total amount of trading activity. Well, my dear students, in today's session, we are just interested in this date column and want to extract the year, month, day, hour, minute, and second from this single feature of our dataset. But before doing that, let me give you a quick recap on the built-in time and data time and the date time module of Python, which probably we have done in our module 2. Let me just import time and let me show you the methods that we have in this time module. Let me show you the time. So these are the methods that we have in time module, and the most basic one is this time method of the time module. Let me run it, time.time. So it has returned a floating point number. Well, my dear students, as you all must be knowing that all Unix-based system, the time is actually expressed as number of seconds passed since Unix epoch, and of course which is midnight 1st January 1970. Well, this time method actually returns a floating point number that represents the number of seconds passed since midnight 1st January 1970. Let me use another method of this, that is this C time. Let me copy these number of seconds and let me use the time.ctime and pass it these seconds, and let's check out. Great. So this C time is passed the number of seconds since Unix epoch, and it returns a string representing the appropriate date time. We can also do it something like this, time.ctime, and instead of mentioning the number of seconds, I can use this time method, which will return the current number of seconds. So this will represent the exact date and time as of now. Of course, in Pakistan, as per the Pakistan Standard Time, which is of course 5 hours ahead of the Coordinated Universal Time, previously known as the Greenwich Mean Time. And if I do something like this, time.ctime, and I pass it to 0, you see it gives you the Unix epoch, that is midnight 1st January 1970, and you can see this 5 hours lag from Pakistan Standard Time to Coordinated Universal Time. Well, my dear students, I strongly recommend you to explore the rest of the methods of this time module at your own time or whenever the need arises. And let me introduce you now to the Python built-in DateTime module. And let me first import it. Import DateTime. Let me just show you the methods. Print the date time. Great. Well, this module actually supports many of the same operations as the time module, but it provides a more object-oriented set of types and also has a limited support for different time zones. Let me just create a datetime object using the datetime method of this datetime module. Datetime.datetime, and I need to pass 3 arguments to it. 2023 is the year, 1 is the month, and 25 is the date. So this has to be a string. Oops. 2023 one, no, separate. These needs to be separate. We'll come up to strings later on. Okay, anyway, so this is the datetime object now. As per the mentioned date, we can also pass the microseconds and the time zone information as well. For the details of the parameters that can be passed to this method, you can get help. You can see the doc string of this method. I think enough about the time and date time module of Python. Let me once again show you the data frame on which we want to play with this date column. Let me show you the data types of different columns of this data frame. D types. So you see this date is actually of object type. So this is not actually a datetime object, rather this is right now a string. Let me verify this. df.ilog, let me show you the first one. Okay, so this is a string, you can see that. Okay, one way to extract information from this column is to parse different parts of this string using the string methods as we have done above, or maybe using some regular expressions. The other way is to convert the data type of this column, date. And this can be done using 2 ways. One is by passing the date column to the parse dates argument of the read CSV method while reading the CSV file. Or if you have already read the CSV file, you can use pandas to_datetime method, which is more commonly used. So let's do that. And over here we have, let me toggle the toolbar and toggle this header as well to have a better view. Now, okay, so we have a better view now. Since we have already read the CSV file, my dear students, and the data is there in the data frame DF, so we can use the to_datetime method, which is used to convert a string to a datetime object. And there are around I think 10 different parameters that you can pass to this to_datetime method, but right now we are just interested in these 3: arg, format, and errors. The only required argument is this first argument, that is arg, which in our case will be a string or maybe a series of string containing a valid datetime value. And before applying it on the date column of the data frame, let us understand the use of these arguments first. Let me do it practically over here. Let me say that pd.to_datetime, and let me pass it this time a string 06-03-2022. So I have passed a date string which says 6 March 2022. Let me execute it. So it has returned me a timestamp. But instead of returning 6 March 2022, it has translated it to 3 June 2022. So it has taken this as the day and this as the month. And this is because the to_date method expects the month before the date. And I can verify this. Let me copy this, paste it over here, and let me show you the month. And the month is 6, so it is not March. Okay. And one way to handle this is to pass a format string to this to underscore datetime method, specifying the appropriate format. And you can always click this link to check out different format specifiers on this Pandas documentation page in order to create appropriate format string as per your datetime format. And in this case, over here, I just want that the date string should have the date first and then the month and then the year. Let me once again copy this over here and let me pass the second argument that says format is equal to, and let me say that first I need to have the date %d hyphen, then I need to have the month %m hyphen, then I need to have the year, a capital Y for the 4-digit years. Let me execute it. And you see this time it has converted it properly. Let me check out, show it to you. Copy, paste, dot, month. And this time it says this is, of course, 6 March 2022. Good. And the way you can check out the month, you can check out the day, you can check out the year. So no need to parse. Great. Fine. My dear students, let me pass an other string to this and mention the time as well. And let me say that I need to convert time as well, and the time is 08 p.m. Let me execute. So this has returned an error, and the error is because of this time format. I need to come up over here, and over here I need to check out the appropriate format specifiers for this purpose, and the one is %i, and the other is this locale equivalent of either AM or PM. Let me fall back over here and let me correct this format string. Let me put a space %i hyphen %p. I think this will do the job. Great. So it has converted the date as well as the time to something that we need. And you see this is 08. Okay, no need to memorize these format specifiers, my dear students. Whenever you want to create a date format string, just visit the mentioned link. So far, so good. Okay, so one more thing. Let me tell you what will happen when the string is not a valid date time string. Let me again copy paste this, and let me put some random alphabets over here and let me execute. It will generate an error again. So this does not match, of course, the format, and this is not an appropriate string. So this has raised an error. This can be handled using the errors argument over here, whose default value is raise. You can pass errors is equal to ignore, in which case it will not raise an error and will keep the string as such without converting it. But better is to use this coerce value, in which case the invalid datetime string will be converted to NAT, that is not a timestamp. Let me do this over here, and let me say comma errors is equal to what is the spelling of this? COERCE. COERCE. So it has not raised an error now, rather has returned me a NAT. Good. I think we are now ready to apply the to_datetime method on the date column of our data frame. Let me show you the data frame again. So this is the data frame, and I just want to convert this data type of this column date, which is right now an object or a string. I want to convert it to a datetime object. Fine. Once again, let me show you the data types. So it is object right now. Great. Let me just copy paste this over here so that I can check out what type of date is there over here. So pd.to_datetime, and I need to pass df date, this column, and the format of course is year, month, and then date. So we have the year, then we have the month, and then we have the date. So it is a bit different over here. So we have the year, we have the month, we have the date, and then we have of course the time, and the time format is space, then we have %I, and then we have a hyphen, and then we have %P. And of course, as you can see, we do have invalid strings, invalid date string under this column. So this will raise an error, and I just don't want that. So I say errors is equal to COERC equals. So let me done it. Great. So it has converted it. So I'm satisfied. Let me say date is equal to this, and let me show you the data frame. Now this is again the data frame, but this time this date column is no more an object type. Let me run this piece of code again. Do note that previously when I ran it, the data type was object, and now when I ran it, the data type is DateTime 64. Great job done. And now it's a piece of cake to do all the parsing. Let me say date, and let me say 0. So this is the first date, and let me say year. So this is the year. Okay, let me do it over here so that you can compare things up. Year, so it is 2020, and month, so it is 3, and day, and that is 13. And let me check out the R as well, and that is 20. And let me check out the month name, month underscore name. So this is our function. It will tell you a string. And let me check out the day name as well. So it is Friday, of course. Great. You can explore rest of the attributes at your own time. Now let me apply these methods or attributes on the entire column, and to do that we can simply say df again for this. So instead of calling this method on a specific value of this column, I am just trying to call this on the entire data frame or series object. So it says series object has no attribute day name. My dear friends, in order to access the values of a series as date, time, we need to use the series.dt. So dt dot. Great. So it has done it. And if I say here, so this is an attribute. So it has successfully done it. Great job done. Okay, so let me show you the df column, df data frame again, and let me just add a new column over here, and let's say that should display the name of that day. Let me say df day of week, and let me say that this should be equal to df date. From the date column, I just want to extract what? Day name, and let me check out the df again. Oops, dta. Excuse me. Great. So we have an additional column, that is day of the week, which represents the day. So we have extracted the day of the week information from this date column. Good job done. Well, my dear friends, now Excuse me. This is the code cell where I have extracted the year, month, day, month name, day name, and finally over here I have used the NumPy's where method to determine if the day is a weekend or not. And if the day name is, of course, Saturday or Sunday, the column will have a value of 1, otherwise 0. I hope this code is making sense now with this background. Let me execute. Great. So you can see the 7 new columns. You can see the 7 new columns. Day of the week, year, month, day, month name, day of the week name, and date is weekend or not. Excuse me. Sorry for I'm having a bad throat these days. So we have extracted all these 7 pieces of information from this date column. And it's very easy now to perform different analytics on it. Let me check out the different methods on this. Let me say that df, I have some issue with the typing as well. Date dot min, I just want to find out the minimum date, so it is this. If I want to find out the max date, so it is this. And if I want to find the difference between these two, because I just want to find out what is the minimum and maximum dates this dataset has. So those were the dates, and that means it contains roughly 986 days and 9 hours records. I hope this is making sense to you all. I think enough about extracting features. Let us now move ahead and see some other example. And this time, let's see the example of combining information from multiple columns to a single column. And let me this time use the famous Titanic dataset for describing this example, that is combining of information. Well, here I'm using the fetch underscore openML method of the datasets module of sklearn to download the dataset from the public openML repository. I think we have done this before as well. And to this method, which I have highlighted, we need to pass the name and version of the dataset to download. And of course, it returns a sklearn bunch object. This Titanic will be a bunch object, which is quite similar to a Python dictionary. And then I have used the data frame method of pandas to create a data frame for better visualization. And this bunch object Titanic has the key data, and it has the key feature names, which contains the columns. I think we have done this. So this will create a data frame containing all the input features. And for adding up the output feature, I have used the target key of this bunch object Titanic and place it in the target column of the data frame. So let me execute it just. Okay, so great. This is a famous Titanic dataset having 1310 rows with 13 input feature columns and one target or the label column. This shows actually the information about the Titanic ship that sank in the North Atlantic Ocean after striking with an iceberg. Well, my dear students, this is a classification problem, but for the time being, I'm not interested in the details of this dataset and doing the classification using some classification algorithm. Right now, I'm just interested in telling you how we can combine multiple columns into one column if the need arises at any time. But before that, let me drop some unnecessary columns from this. Let me drop the name, P-class, ticket, fare, embarked, board, body, home, destination, and target columns, as I don't need them. I'm doing it in place. Now this is a simplistic view of the Titanic dataset, having just the sex, age, sibling, spouse, parent, child, and the cabin column. Just 5 input feature columns. Okay. Right now I just want to merge the information contained in this sibling, spouse, and parent child column in a single column. Well, this sibling spouse column is a numeric column, as you can see, containing count of siblings or spouses aboard. And this parent child column is also a numeric column containing the count of parents or children aboard. Well, this cabin column is also a categorical feature containing two pieces of information, probably the deck, that is B, C, or D, whatever, and then the cabin number. Anyway, we can extract information from this column, but right now we need to merge these two columns, the sibling, spouse, and parent-child. We just want to create a new column or feature, namely, let's suppose travel alone, that should contain a 0 if the person is traveling alone and 1 otherwise. So let me see if I have already written the code for this. Well, yes, I have done that. So for this task, once again, I have used the numpy's where method, which is passed a condition. So this is the condition as the first argument. And if this condition evaluates to true, the second argument is returned, and if the condition evaluates to false, the third argument is returned. And in this condition argument of where method, I am simply checking if the sum of the sibling, spouse, and the parent-child column is greater than 0, then assign a value of 1, otherwise 0. Let me just execute it. Great. So you can see that this person is traveling alone, and this person is having a sibling, spouse, and 2 parent-child. So it has a 1 over here, and so on. I hope this makes sense. So great. Now if you don't need these two columns, that is these two columns, you don't need these two columns, you can drop that, and you can just do something like this. Now we have just 4 columns. The sibling, spouse, and parent-child, these 2 columns have been removed, and we now have a single column, travel alone, that contains the information contained in these 2 columns. Great job done. Well, my dear students, that is all for today's session, I think. Hope it was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning, and Allah Hafiz.